Okay, let's learn about another transformation to the sine and cosine functions. So we already know that A modifies the amplitude and that B modifies the period by 2 pi over B and absolute value of A. Now let's learn about C. C is part of the phase shift of a function. To find the phase shift of a function, you do C over B, so C over the B modifying the X, and the opposite of what it says here. So it says here to do plus C, so really you want to do minus C for the phase shift. So let's do some examples. So let's say there's something sine of X minus pi. The amplitude is 1 because it's just sine. The B is 1, so 2 pi over 1 equals 2 pi, so period is normal. And the phase shift is pi, so pi over the B, so pi over B equals pi, and the opposite of this A, so it's plus pi. So when I say phase shift, that means the entire function is translated over by this amount. So if we were to graph it here with pi over 2, pi, 3 pi over 2, and 2 pi, instead of starting at 0 like it normally does at 0, it would be translated over by pi. So it would start here and go up and down. So that's what a phase shift does. It translates the function left or right, depending on whether it's plus or minus. Now let me get a little bit more in depth into why it's C over B. If a function has a period of pi, then that would modify the phase shift because it would be in proportion to the period. Sorry, that's 2 of x. So amplitude is 1. The period is pi. And the phase shift is pi over 2. So the opposite of what that says is negative pi over 2. So, okay, the period is pi. So let's say this is pi. And the phase shift is minus pi over 2. So it would start over here and look something like this. It doesn't quite reach pi because it's translated pi over 2 units to the left and due to the phase shift. So that's how you use the phase shift.